Can you explain electron spin? Is spin just a parameter that does not relate to a physical spin? Otherwise, there's an axis, gyroscopic effects, but we throw neutron out, etc. Well, it's kind of none of the above and all of the above. So I actually do research in electron paramagnetic resonance, which really focuses on the spin of the electrons, specifically the spin of the electron. And so spin is a quantum mechanical property. It's kind of like saying, well, you've got a wave function. It propagates based on this probabilistic wave, but when you measure it, it becomes localized. In the process of localization, it's kind of spooky action at a distance almost when it suddenly becomes localized. And so you have these kinds of effects that are non-intuitive, because when we talk about the spin of the electron, the spin is actually a superposition of up and down. And it does go through resonate, it does resonate as though it had a gyroscopic axis. So it will, if I put it in a magnetic field and I flip it, it's going to gyroscopically, in a sense, come back to where it was, but it does it quantum mechanically, which means that the spin is actually never going through that space. It's actually just a superposition of up and down. And the relative fraction of up and down mimics the same projection of a regular gyroscope flipping all the way around, the projection on the z-axis, whatever that magnetic field was. And so you can predict that, and it does follow the gyroscopic equations of resonance that you have, say, with a top in a gravitational field or something like that. And so you get them both, but you have to calculate it with quantum mechanics. So it is a quantum mechanical effect, and it does have a gyroscopic axis per se, but the actual spin is really just the quantum mechanical states of up and down, and that's it. And you just simply talk about how much of each does it have. What is it? And then when you measure it, it gets fixed as it's either up and down. But the probability of being up and down is again fixed by those gyroscopic equations, which you have to use quantum mechanics to get the right answer. So it's like the wave function. It's a mathematical formalism that's based on quantum mechanics that gives us the right answer, and it works really good, and it does some really fun research because we use it for nuclear forensics. Using electron paramagnetic resonance, we can literally turn any insulator out there into a radiation detector. You'd have to go into my bio and look at the publications that I've been doing with my students to see that. But yeah, it's a quantum mechanical effect, and it is spin. It's got angular momentum, it's got charge, and it does create a magnetic moment. But you have to use quantum mechanics to get the right value. When you calculate those values, you can't use classical mechanics. So thanks for the question. I hope that answered it and didn't make things worse. I hope you all enjoy the video and you have a great day.